Hello Junior 5, we are going to start our first lesson, which is in Unit 1, which talks about friction. Let's think together, what is friction? If you hold your hands beside each other and you rub them together, you will hear a voice in your hand, right? And you will feel after a while, when you're rubbing it much stronger, that there is a heat inside your hand that you feel. At this moment, when the two solid surfaces, which are your hands, are touching each other, there is a force that exists, which means it appears between your hands, which is called friction force. And this is the force that makes you feel that your hand is getting heat in it. So again, any two surfaces that are touching, which means that they are in contact with each other, when I rub them together or when they are moving together, there is a force that exists between them, and this we call it friction force. The same idea, if I'm holding a ball and I throw it on the floor, it will start to roll up. What will appear between the ball and the floor? What will appear between the moving ball and the floor is the friction force. And let me ask you a question here. When I throw this ball and after a while there is nothing in its way to stop it, after a while, of course, this ball will stop alone. It will not keep moving on. It will stop after a while. What makes this ball stop? What makes this ball stop is the friction force. Of course, you will ask, why will it make it to stop? It will make it stop because the friction force is in opposite direction to the moving object, which means that if the ball is moving forward, the friction force will come opposite to it, not from this side or from this side. No, it comes from in front of it and push it backward. So if the ball is moving forward, the friction force will push it backwards. And that's why even if there's nothing to stop the ball, after a while the ball will stop, because the friction force pushes in the opposite direction, and that's why it will stop. So when you roll a ball on the floor, after a while it slows down gradually and then it stops. Why does it stop? Because of the effect of the force known as friction. So if I come to see what is the definition of the friction force, what does the friction force means? It is a force that exists between two surfaces, any two surfaces that are in contact, which means that they are touching each other, and it affects the movement in which direction? In opposite direction. And as a result, it slows down the motion. The word motion means movement. So again, the friction force is a force that appears between any two surfaces that are in contact, which means they are touching each other, and it affects the movement in opposite direction, slowing down the motion of this object. Okay. We can see in this picture that if I have a ball or a wheel that I am pushing it to the front, the wheel rolls forward and the friction force is in the opposite direction, as you can see in the arrow below. Between the floor and the wheel there is an arrow which is opposite to the movement of the wheel. Okay. If I hold two balls and I roll one on a sandy floor and the other one on a smooth floor like the floor of your classroom, for example, okay, will both balls stop at the same time, or will one of them stop faster than the other? Of course, if I have both floors beside each other, the rough floor and the smooth one, and I throw two balls which are equal in size, I throw them on the both floors, I will find that the ball that's moving on the rough surface or the rough floor will stop before the one on the smooth surface. which means that the ball on the smooth surface will keep on moving for a longer time. So if we ask why does this happen, why will it stop faster on the sandy floor? This is because the friction force on the rough floor is higher than the friction force on the smooth floor, and that's why the ball stops on the rough floor faster than the smooth one. So again, when I throw a ball on a rough surface, it stops faster than the one on the smooth surface. Why is this? Because the friction force between the ball and the rough floor is higher than the friction force between the ball and the smooth surface. And of course, as we said before, that the friction force is in opposite direction to the moving object. So it's the reason why the object stops. So of course, when it increases, the object will stop much faster than it will on a smooth surface that has a low friction force. And by the way, let me ask you a question. Do you ever slip when you are moving on a sandy floor? Of course not. It's very rare to slip when you are moving on something that is rough. You feel that your legs are much stable on a rough surface than on the smooth surface, because the friction on the smooth surface is very, very low, and that's what makes you slip. We are going to take this in lesson 2 in details. So let's keep in the balls and the rough surface and the smooth surface. So from what I just said, this means that the friction force differs according to the type of floor. If the floor is rough, the friction force will increase and the object will stop faster. And if we are moving on a smooth surface, the friction force will decrease, which means it will be much lower, and the object will stop slower. So this means that it will stop. This means that there is friction, but it's just lower. Okay, so on both surfaces there is friction, but on the rough surface the friction is high, on the smooth surface the friction is low. Okay, so let's think together. Does friction only appears between solid objects like a ball and the floor, like my two hands together, like my feet with the floor, for example, while I'm walking? Or can resistance appear, for example, if I'm running in air, when my body touches this air? Can this be also friction? Of course. There are 3 types of friction. When a body hits a solid body or they are moving together, this is called friction. And when I'm running in air, when my body hits this air, this is also called friction between the air and my body. And if I'm swimming, for example, in a swimming pool or in the sea or in whatever, okay, and my body is touching water, my body is solid and the water is liquid. So when my solid body touches this water, there is friction force between the water and my body also. So I have 3 types of friction. Friction that appears between solid objects, and this one I call it friction. The second one is friction between a solid object that is moving in air. So when the air hits this body, this is also called friction, but I give it another name, which is called air resistance. Air resistance. And the same idea, when there is friction between a solid object and water, like for example a human swimming in water, his body touches the water, this is called water resistance. So again, I have 3 types of friction. One which is between solid objects and I call it friction. One between the solid object and the air and I call it air resistance. And the last one is the friction between solid object and water, and this I call it water resistance. We already talked about the friction, so now we are going to talk a little bit in details about the air resistance and the water resistance. First of all, we are going to start with the air resistance. As we said, if any solid body is moving in the air, like for example a human running in air, a car moving, a train moving, whatever, anything that is moving in air, a flying bird, an aeroplane flying in air, anything that's moving in air, when this body touches the air, there is a friction force that appears between them, which I call it air resistance. So again, if I'm asking what is air resistance, it's the friction force resulting from an object's movement through air. Okay, like what? Like a train or a car moving through air. Can we use any other example? Of course, yes. A bird flying in air, an aeroplane flying in air, whatever, anything that's moving in air, there is a friction force which is called air resistance between this object and the air. The second thing is the water resistance, and it's the same idea, but we will change the air into water. Anything that's moving in water, either a ship, a fish, a human being, whatever, anything that's moving inside water, when this water touches this solid body, the friction force appears between them, and we call it water resistance. So what is water resistance? It's the same definition as air resistance, but we are going to remove the word air and put water. So it is the friction force resulting, when does it result? From an object's movement through water. Like what? Like a ship or a fish which is moving through the water. Okay, I want to ask a question. We said that air resistance and water resistance are friction, but one in air and the other one is in water. If I ask you, is the air and water resistance in the same direction of movement or in opposite direction of movement? Of course, you will have to answer me, it's in opposite direction of the moving object. So again, the air resistance and the water resistance both are in opposite direction of the movement. If the fish, for example, is moving forward in water, the water resistance is pushing it backward. And the same thing, if a car is moving forward, the air is pushing it in backwards direction. But of course, the force of the car is much stronger than friction, and that's why it keeps on moving forward. But there is always air resistance between the car body and the air, and the same idea in water. So the air resistance and the water resistance both are in opposite direction of movement, exactly like the friction, because they are types of friction. We have two factors that affect both air and water resistance. What are these two factors? Factor number one is the speed. Factor number two is the surface area. So again, I have two factors that affect air and water resistance. What are they? Speed and surface area. Speed and surface area. So let's see. How does the speed affect the surface area? Let's say, for example, just imagine it with me. When you're moving slowly in the air, do you feel the air hitting you? Of course not. If you're walking normally in a room or in whatever place, you will not feel the air hitting your body. But if you start running very strong or very fast, you will feel the air pushing you back. You will feel the air hitting your body. This means that as the speed increases, as you increase your speed, which means you move faster, the air resistance will increase with you. So again, when I move fast in air, the air resistance will increase. As my speed increases, the air resistance will increase. It's the same idea if I'm riding in a car and I put my hands outside the window. When this car starts to move forward, I will feel it's moving slowly. I will not feel anything. I will just feel some air hitting my hand. But if this car starts to run very, very fast, I will feel my hand is being pushed backwards. Why? Because when the car moves very fast, the air resistance will increase. So as the speed of the car increases, the air resistance also increases, pushing my hand backward. So again, if the speed increases, the air resistance will increase. So let's take it about water. If
بس
I'm
يا
swimming
مشمش
slowly in water, will I feel tired? No. But if I said that I want to reach the other side in 1 minute and I start swimming very fast inside the water, what will happen? When I reach the other side of the swimming pool, I will feel very tired. Why? Because the water was pushing opposite to me much stronger. This means that when I increased my speed in water, the water resistance also increased, and that's what made me feel tired when I reached the other side. So again, if I swim slowly, I will not feel any water resistance around me. It's just water hitting me. But when I start to swim very fast, the water resistance increases and I feel tired. So as the speed increases, both the air resistance and the water resistance will increase. Exactly as you can see in this picture. When the car in the first part up in the picture, the car is moving in a small forward speed, so it's moving very slowly. So as a result, the air resistance in the opposite direction, which is in the red arrow, it's also small. But in the second picture, when the car is moving in a large forward speed, what happened to the air resistance? The air resistance became also large. So this means that the speed increases, both air and water resistance increases. Now let's talk about the second factor, which is the surface area. What does the surface area do to the air resistance and the water resistance? Let's imagine it together. First of all, the air resistance. If I'm moving in air, putting my hand beside me, I'm running in air and my hand is beside me. Will I be faster while running? Or if I'm running and opening my hands? Just try it كده once to run opening your hands on both sides, or you are putting your hands beside you as normal and you are running. Of course, when you are running with your hand beside you, you will be much faster than when you are opening your hands. Let's think together why when you open your hands you become slower. Because when you open your hands, you increase your surface area. You increase the amount of the parts in your body that is hitting the air. So as a result, the air that hits you is much higher, and as a result, the air resistance will increase. So one more time again, try to imagine with me. As I increase, which means I become bigger in size, as I increase my body surface area, the amount of air hitting me increases, and as a result, the air resistance also will increase with me. Right? Okay, let's take it in another way. If a big bus is moving and a small bus is moving, and a small car, is moving beside it, what will happen? Which one will move faster? Which one will be hit by the air more? Of course, the bus will be hit more, and as a result, we can say that as the surface area, because the surface area of a bus is much bigger than that of a small car, so as the surface area increases, the amount of air hitting the bus will increase, and as a result, the air resistance also will increase. Let's take it in another words. Okay, let's talk about the water. When I move in the water, or let's take it in another way, a big fish and a small fish, which one will swim faster in the water? Let's say, for example, a whale or a small fish that like the ones we eat. Of course, the small fish moves much faster than a big fish. Why? Because the amount of water hitting the big fish like a whale is much bigger than that water that is hitting the small fish. So when the amount of water increases, this means that the water resistance increases. So again, as the surface area increases, which means that the size of the fish becomes bigger, the amount of water hitting it will increase, and as a result the water resistance will increase. Exactly like another example, which is a big ship and a small boat. Which one will move faster? Of course the small boat will move faster. Why? Because the amount of water hitting it, in contact with it, is much less than that with the big ship. So the water resistance is much bigger when the surface area is bigger. So again, as the surface area increases, both the air resistance and the water resistance will increase. And here we have another example, which is the parachute. Let's talk about it. This will show you how the air resistance increases when the surface area increases. When someone is making skydiving, where they go up high in the sky with a plane and then they jump from this plane, just jumping to skydive, and then when they start to move downwards until they are very close to the ground, they open the parachute. Why? When they open the parachute, they are pulled up high in the sky. Why don't they fall down? This is because the surface area of the parachute is very big, and because it's very big, the amount of air that pushes in it is big, and as a result the air resistance is very high, so it pulls the parachute upwards. Again, the parachute surface area is very big, and as a result the air resistance that is pushing it is big, and that's why the parachute is pulled upwards. So again, we have two factors affecting air resistance and water resistance. One of them is the speed, the other one is the surface area. As the speed increases, as the object is moving faster, both air resistance and water resistance will increase. The same idea in the surface area. As the surface area of the object moving either in air or in water increases, both air and water resistance increases. As we were talking before, we said that the surface area affects both air and water resistance, right? Okay, if we watch the pictures in front of us of the train and the ship, one of them is moving in air and the other one is moving in water. As we can see them, from the front part of the train and of the ship, they have a different shape from the rest of the body of the object, which means that from the front part they appear as if they are small from the front or thin, and then at the back they become bigger in size. This shape from the front, we call it streamline shape. We call it what? We call it streamline shape. What does streamline mean? It means that they are thinner from the front than from the back. This shape that we see in the picture of the front part of the ship and the train, both are called streamline shape. Also, the front part of a flying bird in the sky, you can see the shape of the bird. It's thin from the front with its beak, and then from the back it's the normal size of the bird. This also we call it streamline shape. The same idea is the fish. From the front part where the mouth is and the eyes, the fish appears to be streamlined. It's thin from the front, and then from the back it becomes bigger in size. Differs from a size of a fish to other size of a fish. One is a little bit small, one is a little bit big, but all in all, from the front part they are thinner from the back part. Okay, this shape from the front, we call it streamline shape. So if I'm asking, why does the train or the ship or the bird or the fish have a streamline shape? Why it's not as a whole the same size, the big size, and that's it? This is because the first part of a moving object, either in air or in water, is the most important part. If it's thin, the amount of air or water hitting it is smaller, And when this is smaller, this means that the air resistance and the water resistance will be less, which means that it can move faster. Let's take it one by one. First of all, we are going to talk about the train which is moving in air. When the train is small or thin from the front part, this means that the amount of air hitting the train is small. And when the amount of air hitting the train from the front part is small, this means that the train will move with a higher speed. It will make it move faster because there's no much air pushing it backwards. So it's easier for the train to move. And that's why we make it streamline shape. The same idea in the ship, but it differs only that it's moving in water, not in air. When the ship is moving in water and it's streamline in shape, the amount of water that's hitting the ship is very small, or it's less. So because it's less, it can move faster in water than if it's not streamlined, because the amount of water will hit it, it's bigger, so the fish will move slower. And that's why the objects are in streamline shape. So again, since the surface area affects both the air and the water resistance, so the objects that fly or swim have a streamline shape. Streamline shape means that it's thinner from the front than the rest of the body. Why it's streamline shape? To reduce or decrease the surface area and so move faster, either in air or in water. We are done now with lesson 1, which is the friction. So as we said, friction is a force that appears between any two objects that are in contact with each other, and it affects the movement in opposite direction. And we said any object that moves on a rough surface, this slows down, this increases the friction, so it slows down the object and makes it stop faster, while the one that's moving on a smooth surface will take a longer time to stop because the friction is low. And we said that we have 3 types of friction: air resistance, water resistance. Friction is between solid objects. Air resistance is between a solid object and air. Water resistance is between a solid object and water. And we said that we have 2 factors that affect air and water resistance, which are speed and surface area. Speed and surface area. And we said as the speed increases, both air resistance and water resistance increases, and as the as the surface area increases, both also air and water resistance increases. And to prevent the slow movement of any huge object, we made its shape streamline shape. Why did we make it in streamline shape? To decrease the surface area, to make it move easier either in air or in water. So we make it streamline shape. Lesson 1 is over in this unit. Now we are going to start lesson 2, which is application of friction, or friction applications. What are the friction applications? Friction applications, we are going to show you in what do we use friction, how do we use friction, why is friction present, why did God exist this force between moving objects. And of course, as anything in the world, friction has advantages and has disadvantages. So it has advantages and disadvantages. Let's see the advantages. Advantage number 1, advantage which is the good thing that the friction does. Number 1, it helps in moving a car forward. When we are riding a car and we start to move the car, if there is no friction between the tires of the car and the street, the floor of the street, the car will slip down. It will not be just moving forward. There is nothing that will make it stop. It will keep on moving, slipping down until you hit in anything to stop. So what is the advantage of friction? It makes a car move forward. and it also helps in stopping the car. So in both things, it helps the car to move forward without slipping. So if there's no friction, the car of course will move because I'm pressing on it and I'm letting it to move, I'm putting it on. But it will, if there's no friction, the car will start to slip on the street. And it also helps in stopping the car. When I press the brakes, the presence of friction between the floor and the tires will help it to stop. The second advantage I have is walking without slipping down. It's the same idea of the car, and as I said in lesson 1, when I'm walking on the floor, there is a friction force between my foot and the floor I'm moving on. So if there is no friction, as I am moving, I will keep on slipping down. Each time I will stand up and start to move, there is nothing that holds me with the floor. Friction, because it's in opposite direction, it helps me to stay stable standing on the floor. If there is no friction, I'll keep slipping on down. And that's why we say that the smooth surface, as you can see in the picture, the smooth surface is slippery. Why do we say it's slippery? Because it has low friction, and that's why it's easy to slip down when you are running on a smooth floor than when you are running on a rough floor. When you are moving on a smooth floor, you can fall very easily and slip down. But when you are moving on a rough floor, of course, it's very hard to slip down because the friction is very high. And the last advantage we are going to take in lesson 2 is the lighting up a match. Friction force helps me to light a match. How? When I take a match and I get the match box and I start to rub the match in the box, in the side of the box, as you can see in the picture, what happens? I will find the match lighting up. How does it light up? Because between the match and the box there is a friction force that appears. And as I said in the beginning of the lesson, when you rubbed your hand together, which makes a friction force between them, you feel your hands starting to get hot. And as I said, friction makes heat, produces heat when two objects are rubbing together. So when I rub the match with the side of the matchbox, there is a friction force that exists between them with heat, which makes the match light up. So again, I have 3 advantages. I can move a car forward without slipping down or without slipping to hit in anything. Number 2, walking without slipping down. The friction helps me to walk without falling down. And number 3, it helps me to light up a match because it produces heat, which helps in lighting the match up. And we are going to take now the disadvantages of friction, and it's only one disadvantage. The disadvantage of friction is when a machine works, as you can see in the picture, there are parts of the machine, internal parts of the machine are touching each other to make this machine work. Okay? Of course, when these parts start moving together with each other, there is a friction force that will appear between them. And as we said before, friction force produces heat. So when the heat is produced, if nothing makes this heat to cool down, what will happen inside the machine when it becomes filled with heat due to friction? The machine will get burned or it will get damaged due to this heat that is produced as a result of friction. So by time, the machine will get damaged and no longer can be used. So this is a disadvantage of friction. So let's take it in other words. This means that when the friction produces heat, I can take it as an advantage and a disadvantage. When it produces heat while I'm lighting up a match, this is an advantage because I need to light the match with this heat. But inside the machines, when I have parts that are touching each other and moving, when friction appears between them, heat is also produced. And when the heat is produced, it causes the damage of the internal parts of machines. So this is a very big disadvantage, and there are many ways to prevent this friction to happen. Like, for example, I will only tell you one example because it's not on you. I can tell you that we can put oil between these parts, so the oil is smooth, so it will decrease the friction force, and when the friction force decreases, there will be no heat or will be very low heat, so the internal parts will not get damaged. And there are many other ways to try to reduce or decrease the friction, but as we said, one of the disadvantages of friction is to damage the internal parts of machines.